Hello everyone, welcome to today's webinar. My name is Ram Prasad. I'm a senior field application engineer at Econ Systems. To give a short intro about myself, I have been working at Econ Systems for more than 8 years. I started my career as a software engineer and currently I'm working as part of the industrial business unit here at Econ Systems. I have been working with several customers across multiple industries, supporting them right from the conceptual stage to product launch, and by helping them integrate the right vision technology into their products. Along with me, I have Mr. Prabhu Kumar, Chief Technology Officer at Econ Systems. He comes with a rich experience of more than 15 years in the embedded vision space with deep knowledge in USB cameras, embedded vision cameras, vision algorithms, and FPGAs. He has built 50 plus camera solutions spanning various domains such as medical, industrial, agriculture, retail, biometrics, and more. Currently, Prabhu's focus is to build smart camera solutions that power new age AI-based applications. The topic of today's webinar is what is time-of-flight camera and how it enhances 3D vision applications. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box. I will bring them up during the question and answer session at the end of this presentation. We would love to hear from you. Also, a recorded version of this webinar will be available in YouTube after the session. It will also be shared with all the registrants by email. For those of you just joining in, welcome to the webinar. The agenda for today's session would be to give you a walkthrough of what time-of-flight technology is, how it differs from other depth mapping technologies, and the advantages of using an RGBD camera. We will introduce you to DepthVista, Econ Systems 3D ToF camera. We will also be covering some of the use cases where a ToF camera can be used for depth sensing. Before going into the session, I would like to give a short introduction of Econ Systems, who we are, what we do, and what our value proposition are. Econ Systems is a leading manufacturer of OEM camera products and embedded vision solution provider. We have been in the field for the past 18 years with more than 300 customers using our cameras in their products. Econ Systems is an ISO 9001:2015 certified company and we have shipped over 2 million cameras across the world. Econ offers USB 3.0, MIPI and GMSL cameras for embedded vision applications and provides camera solutions across various markets like industrial automation, smart city development, agriculture, retail applications like smart checkout and biometrics, and medical use cases like life sciences, point of care devices, etc. Econ Systems has a very strong partner ecosystem to provide complete embedded vision solution. We are working closely with technology partners like Sony, OmniVision, and Onsemi for image sensors. Our CPU partners are NVIDIA, NXP, Qualcomm, TI, and our interface partners include Cypress, Maxim, and a few others. We also have our distribution partners across geographies. Silicon Highway in UK and Europe, CRG Electronics in Israel, Silicon Device and Ryoyo in Japan, and we also have Cythus in South Korea. These are some of the Econ's value propositions that helps us stand out. Econ has been in the embedded vision space for almost 2 decades, providing solutions to numerous customers. We know the pain points of every camera-based application in every industry. Most of our camera products has an onboard image signal processor and we have rich experience in tuning the ISP to get best image quality. Econ Systems has an in-house imaging laboratory and ISP experts who can fine-tune the ISP based on end application requirements. Econ Systems has off-the-shelf products that can be used in multiple applications. We also provide customization services for our cameras to make it more suitable for the end application. Over 300 plus products are in the market which are using Econ Systems cameras. We work right from the conceptual stage to the deployment stage. By traveling with the customer till their product launch, Econ not only acts as a camera supplier but also a technology partner to our customers. Any camera you buy directly from Econ System web store carries a warranty of 3 years. The typical mean time between failure for our cameras is 8 years. Econ System has been supporting cameras for various industrial and medical customers where longer lifetime support is required. When we launch our product in the market, we make sure that they are available for at least 5 to 10 years. Now let us dive into the topic of discussion today. In recent years, 3D vision technologies have evolved significantly, improving their accuracy, range, and low light performance. And there has been a surge in demand for depth sensing in many embedded vision applications. Some of the most popular applications where a depth camera is used are autonomous mobile robots, automated guided vehicles, remote patient monitoring, and people counting systems. While we all understand what a depth camera is, the concept of ToF and RGBD camera is a mystery to many. We will demystify it for you in this webinar. Without further ado, let me pass the baton to Prabhu. Over to you, Prabhu.
Thanks, Ram, for the introduction. Hi everyone, I am Prabhu Kumar and I am CTO at Econ Systems. I will be first walking you through what time-of-flight technology is, what are the key components of time-of-flight camera. We will also do a detailed comparison of various 3D depth mapping technologies. And last but not the least, we will also learn more about the technical features of DepthVista, which is the latest 3D time-of-flight camera from Econ System. That said, let us first look at how the time-of-flight technology works. As you might be knowing, time-of-flight sensors work based on the light illumination technique, wherein the sensor emits light to the target object and captures the reflection from it. The depth or distance to the target object is then calculated using the time it takes for the light to return to the sensor. The calculation is done using a simple formula where distance equals time multiplied by speed. In this case, the distance is obtained by multiplying the time of flight by the speed of the light. This value is then divided by 2 to account for the back and forth travel to obtain the final depth value. Now that we understood how the technology works, let us look at the key components of time-of-flight camera. The very core of a time-of-flight camera are the sensor and the sensor module. The key function of the sensor is to collect the light reflected from the target object. In addition to the sensor module also houses the optics that typically come with a larger aperture for collecting more light. The next key component of time-of-flight camera is the light source. As the term suggests, it emits light to the target object. The most common types of light sources used are VC cell or LEDs, and typically light in the near infrared spectrum with a wavelength of either 850 nanometer or 940 nanometer is used. The VC cell system uses a diffuser to ensure uniform surface illumination by diverging the light in front of the image sensor. The third component of the time-of-flight camera is the depth processor. The depth processor can be called the brain of a time-of-flight camera, where its key function is to convert the raw pixel data obtained from the time-of-flight sensor into a depth information. It also helps in noise filtering to improve the output depth quality. In addition, it provides a passive 2D infrared images that can be used for other end applications. To help you understand the concept better, here is what the output from the time-of-flight camera will look like. This is a depth map where red color represents nearby objects and blue color represents farthest objects in the scene. Let us now do a quick comparison of various depth mapping technologies available in the market, which are stereo vision, structured light, time of flight. Let us start with the working principle. Stereo vision works by comparing disparities in images from two 2D sensors, whereas a time of flight camera measures depth based on a time taken by light from the source to travel to target object. In structured light, depth is calculated by analyzing distortions of illuminated patterns on the 3D surface. Coming to software complexity, stereo cameras involve complex disparity computations to calculate depth, which adds to the CPU load on the host side. In case of the structured light, this complexity is lower, and in time of flight cameras, this is the lowest as the depth map is directly obtained from the camera. When it comes to cost, stereo cameras tend to be cheaper because they are built using a CMOS sensors. Among the three, structured light is the most expensive. In general, time of flight cameras are cheaper than structured light system, making them a viable option for a lot of depth-based embedded vision applications. Let us now look at how these technologies differ with respect to accuracy. Structured light tends to be more accurate than time of flight, while stereo cameras pose more accuracy related challenges. And at the same time of flight cameras come with a medium accuracy. Stereo cameras offer depth measurement with a maximum accuracy in the range of centimeters, whereas the accuracy of time of flight cameras is in the range of millimeters. Structured light offers even better accuracy with a variance as low as few millimeters at its best. Even when it comes to range, structured light images and time of flight cameras are far better compared to stereo cameras. The next parameter is low light performance. Here as well, structured light and time of flight technologies beat stereo cameras. Since time of flight cameras use a VC cell as the light source, they do not require any ambient light for optimal performance. Let us now discuss compactness. Time of flight cameras offer an impressive form factor with their compactness. This is because of the fact that sensor and illumination can be placed together, unlike in a stereo camera where the baseline cannot be reduced beyond a point. Structured light will fall in between time of flight and stereo technologies in terms of compactness. So I hope you all were able to develop a good understanding of how the time of flight technology works and how it compares with other popular 3D depth mapping technologies. If you have any questions around this, feel free to drop them in a chat section. We shall take them up during a QA session towards the end of this webinar. With that, let us jump into next section where we look at it in details of features of the DepthVista, which is Econ's latest 3D depth camera. DepthVista is the 3D time of flight camera that houses a depth sensor and a RGB sensor. It is pre-calibrated camera with an enclosure that comes with a USB interface and a tripod mount. The best way to understand the hardware components of the camera would be to look at its block diagram. For depth mapping, DepthVista uses a VGA depth sensor and a VC cell light source that operates at 850 nanometer. For 2D imaging, the camera uses a 2 megapixel color global shutter sensor along with an ISP. One of the differentiators of DepthVista is that it is an RGBD camera that delivers both the depth and RGB data in a single frame. Using an FPGA, the images from the depth sensor and RGB sensor are synchronously combined. This data is then sent to the host through the USB controller. This is very helpful in applications that need to detect color alongside the depth data. We will discuss more on the target applications of DepthVista in the later section. DepthVista also comes with a inbuilt IMU sensor that can be used to determine motion, orientation and heading. In addition, there is a temperature sensor on board for the purpose of measuring the temperature of the electronic components of the camera. This makes it suitable for use in industrial environment. Let us now look at the SDKs that comes with a DepthVista. Like the other USB based cameras offered by Econ system, DepthVista is a UEC compliant and does not require any additional drivers to be installed on the host site, whether you are using in Windows or a Linux based system. DepthVista also comes with 2 modes of operation called the near mode and the far mode. While the near mode measures depth from 0.2 to 1.2 meters, the far mode has a working range of 1 meter to 6 meter. It has the ability to get depth and RGB frames seamlessly leveraging the SDK's APIs without having to write any complex code. So that wraps up the key features of DepthVista. Next, I hand it over to Ram to explain some of the benefits and applications of this time-of-flight camera. Over to you, Ram.
Thank you, Prabhu, for the introduction about ToF technology and the DepthVista camera. Now, let us look at the advantages of DepthVista over normal ToF cameras. Depth sensors like LiDARs and ToF cameras use lighting techniques to create depth maps or 3D maps. However, for depth measurement, color information is not required by these systems. Also, adding it would increase the computation load on the camera systems as well. For these reasons, an ordinary depth camera does not come with the option to deliver color or RGB data. DepthVista, with its advanced technology, combines both RGB and the depth data without any major compute load on the camera and outputs 30 frames per second. The RGB camera in DepthVista supports HD and Full HD resolutions, which are suitable for algorithms to do vision analysis. In RGBD mode, the camera outputs both the depth and RGB data in a single frame without any additional processing in the host. This is particularly useful in applications that need to identify the type and nature of objects in the scene along with measuring their depth. And the ability to deliver these two types of data in a single frame makes the camera even more suitable for applications such as facial recognition based anti-spoofing systems and people counting devices. Another key feature supported by DepthVista is that it can get the depth data directly from the module. We don't need to perform any kind of depth processing in the host to get depth information. And this saves a lot of computation power in the host platform, which can be utilized for other operations. This provides an improved frame rate and ready to use frames in the host platform. DepthVista supports near and far mode operations with an accuracy of less than 1%. The near range mode operates between 20 cm and 1.2 meter, which can be used in applications like box dimension measurement. And in far mode, we can use the camera from 1 meter to 6.5 meters, which is suitable for autonomous robot navigation. With the help of an active light source, DepthVista can be operated even under low light conditions, which would be helpful in places like warehouses where lighting conditions vary quite a bit. The camera also comes in a compact metal enclosure with a standard mounting hole to use it with a tripod setup. Now, let us see some of the use cases where a ToF camera can be used across industrial, retail and medical applications, and how Econ's 3D time-of-flight camera DepthVista would be a right fit for them. First is AMRs or autonomous mobile robots. ToF cameras have been reinventing warehouse operation by equipping AGVs and AMRs with depth sensing intelligence. These cameras help robots to perceive their surroundings and capture depth imaging data to complete their task optimally, reliably and safely. Autonomous mobile robots such as cleaning robots, goods to person robots, service robots and companion robots can be equipped with DepthVista. Most of the AMRs use GPS signals to identify their position in their known territory. But for indoor applications like warehouses, this would be impractical. Using DepthVista, AMRs can now localize themselves. ToF cameras help AMRs create a map in unknown environments by measuring the transit time of the reflected light from the target object. So it uses the SLAM algorithm, which requires 3D depth data to provide accurate mapping information. They can capture 3D depth data by knowing the distance from the reference point in a map, and by using triangulation, the AMR can pinpoint its exact position. This enables seamless localization, making navigation easy and safe. DepthVista has a global shutter camera which also can be used to scan and find markers for navigation purpose. DepthVista using the onboard illumination can work well under low light condition in a warehouse. AMRs are likely to encounter objects during their navigation within a warehouse. Hence, they require precise information about their surroundings to avoid any collision with these obstacles. Using the 3D depth information along with the RGB data from DepthVista, AMRs can identify the obstacle and the distance. With this information, they can easily avoid collisions and accidents by planning a new path to reach the destination. DepthVista can also be used to enable safety features in applications where humans and collaborative robots work together in order to prevent collision with humans or to provide interactive gesture control. The second application we will look at is logistics. Time-of-flight cameras are actively used in the logistics industry. The main application DepthVista can be used for is box measurement, where we can quickly get the length, width and height of the packages using the depth information. DepthVista can also be used in real-time box volume measurement systems to effectively use the space available in a packaging box without any wastage. Volume and dimension measurement is possible regardless of the orientation of the packaging box. Ready-to-use frames along with depth data from DepthVista is helpful for this application where speed and accuracy are important. Optimal packaging decreases the risk of objects getting damaged during transportation. Thus, we can reduce the number of returns due to damages, helping companies increase their brand value. In addition, we can use DepthVista to look for empty shelves in warehouses using the depth data and identify the shelf position marker for better inventory management. In some use cases, the IR data from DepthVista is used to capture the barcode information from the packages. The next application is people counting. One of the common use cases of time-of-flight cameras in retail industry is people counting. ToF cameras are used in automatic doors and elevators in various environments like malls, supermarkets, offices and public transportation systems for people counting and tracking the traffic flow. This offers critical insights into a variety of key business metrics from periodic occupancy counting to space optimization. This application is also aimed at public transportation systems to determine the degree of congestion. DepthVista, with its compact form factor, can be easily mounted at important entrances and exits and effectively and quickly count the number of people entering and leaving the door using just the depth data. By this way, the identity of the person is not captured and this protects the personal privacy of the visitors. Since DepthVista uses an active infrared emission, we can detect people, objects and rest of the scene without being affected by the color of the ground or people's clothing. For instance, a person wearing white clothes and passing on a white floor still be detected effectively. Accurate information along with high frame rate is one of the key advantages of using DepthVista for people counting systems. In addition to counting people entering and exiting, room occupancy data provided by people counting systems can be utilized to optimize HVAC and lighting systems according to the user's need. The use of people counting technology to automate ventilation, heating and lighting systems can lead to sizable reduction in energy usage, also resulting in considerable reduction in both carbon emission and energy expenditure. The last use case we will learn about is remote patient monitoring. Remote patient monitoring is one of the key medical applications where a ToF camera can be used. Remote patient monitoring was already a common practice before the COVID-19 crisis, but in the wake of the pandemic, RPM gained prominence as one of the most effective programs adopted to support the wellness and care of patients. What was once used only for chronic conditions expanded to those with chronic or acute conditions as direct contact with patients became restricted. Patient monitoring is essential to healthcare and using embedded camera technology is gaining popularity to help prevent acute condition from becoming chronic or worse. However, people remain cautious about the level of privacy, especially in the healthcare world. This is where time of flight camera provides a technological solution for patient monitoring by ensuring privacy. A time of flight camera can ensure patient anonymity in remote patient monitoring setups, as key events such as patient falls and movements can be detected by capturing merely the depth data of the monitored scene and not the RGB or color data. By using the depth mode supported in DepthVista, you can set it to use only the depth information from the camera. Since we are using a low powered pulsed infrared light for depth measurement and illumination, DepthVista ensures safety to patients' eyes as well. The VC cells provides necessary illumination for the system, and there is no need to use extra lighting for the camera system. Some of the other applications include indoor farming, where DepthVista can be used to monitor plant growth, gesture recognition, digital signages, where the RGBD can be used to identify the distance, gender, and age of the audience for targeted advertisements. Other applications include fitness applications by using pose estimation and more. With this information, we wrap up today's session. Please let us know your questions by posting them in the questions box. If you are envisioning a vision product and need clarification, please write to us at camerasolutions@econsystems.com. To know more about our DepthVista camera, please visit our website. Let's move on to the question and answer session. Yeah. Now we have our first question. Can we use DepthVista camera without using external power? Yeah, so DepthVista has a VC cell light source which requires external power to operate. Without the external power, the camera can still be used, but we can use only in the RGB mode. The next question is, does DepthVista support IP67 rated enclosure? DepthVista camera is primarily aimed to be used in indoor environments. So IP67 rated enclosure might not be required in most of these cases. In case you need an IP67 rated enclosure for dusty indoor environments, Econ Systems can customize the camera to offer the same. So if you have any specific requirements on the enclosure, please share your requirements to camerasolutions@econsystems.com.
Can we use DepthVista in outdoor conditions? As the laser diodes used in this camera operate in 850 nanometer NIR range, the likelihood of interference from sunlight is very high if you use it in outdoor applications. This is the reason DepthVista works good only in indoors. For outdoors, we have to use 940 nanometer VC cell to get better performance under sunlight. We are working on our next version of camera that would come up with a 940 nanometer lighting. The next question is like, is it available over other interfaces like MIPI or GMSL? Yes, we are working on variants of ToF camera with only MIPI and GMSL interface for embedded vision processors, which we can expect in like Q4 2022.
Okay. So can we reduce or increase the depth range provided in the DepthVista camera? Yes, we can reduce or increase the depth range by adjusting the VC cell intensity or by increasing the number of VC cells provided in the camera. So by increasing or decreasing the VC cells, we can adjust the depth range. But this is not part of the default camera. We need to do it as a separate customization effort. So if you have any specific customization requests, please share your requirements to camerasolutions@econsystems.com.
So what is the FOV for RGB camera? The FOV is like 90-degree diagonal, 80-degree horizontal FOV, 55-degree vertical FOV. Is it camera interface support Jetson or Raspberry Pi ARM CPU platform? Yeah, as I mentioned before, like we are working on a MIPI variant. So the current DepthVista supports only USB variant, USB version. Are these ToF and RGB sensors synchronized? Yes, the ToF sensor and RGB are synchronized. So with the help of an FPGA, so we capture the depth frame as well as RGB frame and like merge it as a single frame and send it to the PC as a single frame. What is the maximum measure distance for depth camera? Currently we support like two modes, near mode and far mode. The far mode can go up to like 6 meters.
Okay. Do you have any other upcoming models in the pipeline? I just need the depth camera. RGB might not be needed for my use case. So we are working on ToF only mode in our upcoming version. So that will be using the MIPI interface. So we will be we'll be launching the ToF camera over MIPI interface soon. So if you have any questions, please type the questions in the chat box so that we can answer. Yeah, we can wait for a couple of minutes, maybe for other questions. Yeah, so we have another question now. What is the maximum resolution and frame rate supported for depth camera? The maximum resolution supported by the depth camera is VGA, that is 640 x 480, and the camera can stream at 30 frames per second. This is the maximum for the depth camera. The RGB camera can support up to 2.3 megapixel resolution, that is 1920 x 1200 at 30 frames per second. Okay, thank you everyone for your interesting questions. Yeah, we will be sending the video to all the registrants. Thanks for your time, and I hope this webinar is helpful for you to understand our time of flight camera as well as DepthVista camera. Thank you.